Hello everyone, welcome to the July version of Cipher. Crazy to think that this year is already just flying by. My goodness. So I thought today we'd spend some time in the lab. So I am going to demo a few fun things that I enjoy a lot. We've talked many times about a SIEM, Security Information and Events Management, SIEM. Cyber Samurai is familiar with several of them, but Splunk is the obvious choice. It's probably the most mature product. I've been using it around 12-ish years, and so any SIEM, any well-tuned SIEM can show you your environment and what's happening, whether cloud, on-prem, networking, Linux, Windows, IoT stuff, your printers. I mean, just whatever you want that can create logs. You can pull that into your SIEM and get useful information out of it. So I would like to show essentially an entire attack chain against Linux and against Windows, and how a SIEM could really be used for almost every step of the way. It gives your IT or security several chances to be notified that something is happening so that they can intervene. That's the biggest benefit of a SIEM is it can be used for sysadmin stuff also, but its primary use is to make it so that when a hacker is in your environment, if you've done the previous security work of hardening your environment, it's going to be difficult to move around. They'll need to be loud, and any well-tuned SIEM will catch that, and you can get alerts, and you can know, like, hey, there's somebody else in here. They're on this IP address. These credentials are probably compromised. It doesn't give you all the ability to react per se. You still need to get into your managed detection and response, your MDR, your Sentinel-1s, your CrowdStrike, and start actually making new rules about blocking this IP address, seeing everywhere where those credentials are logged in, that sort of stuff. But SIEMs are really, honestly, it's probably the most fun part of my job. Is MDRs are fun when you're playing chess in real time with somebody on a network. I mean, that can be enjoyable, but by and large, like, the SIEM is doing those forensics afterwards, and also ahead of time too, of just knowing, okay, I've been studying data breaches for since 2012, so whatever that is, 14 years. Been reading them. Why I think that's fun reading, I don't know. I have a weird mind apparently, but just getting familiar with the whole know thy enemy thing of just, this is what hackers are doing, this is their logic, these are the kind of things they're after, this is how they pivoted networks, they're using tools like this. AI has just changed, it's just the newest tool, but the real mechanics of how they operate, how they think, doesn't really change that much. And so SIEMs can be tuned in a way to whatever their end goal is, like catch them, give you those opportunities. So I'd like to jump into my lab here. So this is all just disconnected network here. Let's kind of play around a little bit. So what I've got over here is a server 2022. So this is my domain controller, and let's see what else I've got in here. I've got a Linux server. So these are the network. So this is the company's assets. So these are their Linux servers and their Windows servers. Come on, little guy. Let's go. Hello. And then if it'll load, I've got a Kali Linux box here. So obviously Kali Linux is the hacker OS of choice. So that's how they're going to come in. Here we go. So everything's just all kind of set up with the lab, not secure. It's fine. It's just a lab. So anyway, first, right off the bat, when a hacker, so I'll preface this a little bit. Let's pretend a hacker is on your network. How they got on your network, who knows? Probably purchased VPN credentials, that sort of thing, got in that way, or maybe they're on a workstation. They're running malicious code through one of your users' browsers and trying to pivot through the network. However they got on your network, let's pretend that they're on your network. So MITRE has done a very good job of kind of documenting all these types of attack chains and categorizing, this is reconnaissance, this is, initial exploitation, this is exploitation, this is permanent access, all that sort of stuff. But almost always hacking starts with reconnaissance. They need to know what's out there, what's the versions of the stuff out there, what the vulnerabilities on those versions. And so all of that involves probing. So they're going to hit the network. I've seen in some of my investigations where they will just pound all possible IP addresses for specific ports. Like one of the commands they might run is this. So this is just an mmap command. It's just going to check for port 22 if it's open, 80, so that's web traffic, 443 is web traffic, 3389, that's Windows Remote Desktop. That's how you administer a Windows computer remotely. 9585 and 470001, those are all Windows remote management stuff. And then 22 is on Linux, how you would remotely manage Linux. So in my investigations, they'll pretty much pound all possible IP addresses here. Since I know my environment, I'm just going to scan from 11 to 30 just to create this traffic. So they might execute something like this. And it's just going to go through every one of those IP addresses and just document like, okay, yep, this was open, this was open, this was open. Interesting, it didn't find 24, so I wonder if this is why this is mad. I wonder if this is just needs a good reboot. Let's see. Aren't live demos fun? Hey, look, we have visuals now. All right, cool. Alrighty, I would seriously recommend get a lab. Oh my goodness, it is so much fun having a lab. You can just prototype anything, test anything. For building out a SIEM, I mean, they're just such a good idea just to like get your lab environment, log into your SIEM, and then just do stupid stuff. Like, hey, if I do this, first of all, what happens? Does it break everything or whatever? But then second of all, how's it show up in the logs? Like, you can only create an alert for things that could happen or have happened, the actual syntax of like what you need to tune your Splunk, your SIEM of choice to do. So, highly recommend get yourself a lab like this. Okay, so let's try this again, because there should be, there actually are only two. So there's server Linux. The problem of doing this too many times. Okay, so when a hacker runs that, they're going to look at this and they're going to see, okay, so .11 has SSH open. Okay, so it may be a Linux server. I happen to know this is a Windows server because 3389 is open. Okay, so that means this is most likely a Windows server. This one only has SSH open. Okay, so this is a Linux server. So let's go against this this server first. So a hacker would only know the IP address at first probably, and may be able to look up like friendly names or whatever. But one of the first things they might do is like, first of all, they might try to remote in. Well, first of all, let me show you, even just this action right here, just scanning the network can be seen from Splunk. So let me this will happen naturally in 5 minutes. Every 5 minutes, Splunk will send off logs to the Splunk server. But since this is a demo, let's just go ahead and restart this. So all this does is like, it just stops that 5-minute timer and says, hey, send your logs now. That's all this command does. So just restarting here. So Splunk sends some logs. So your SIEM, that will be a server that is either, you can get cloud ones or on-prem. This is my little lab, and so it's just like a little Linux server I run here. So in here, I've created these dashboards. So it's security Linux or server Linux. So right here, if we filter on time, so 12:27 is 12:30. Okay, so right here this is the host it came from, so I just named it Ubuntu 24 because that's what it is, because it's a lab and I don't care. 5985 was hit from this IP address. Okay, so this is opportunity number one for your IT or security department to react. So first of all, like, not just anything should be trying to hit this. That is a pretty highly elevated port. It should be either your IT department or your security department for testing or something. But really, this should be an alert. Someone should be getting an email looking into, whoa, something just happened. Just the fact that that IP address also hit these other ports, hit 22, this essentially is telling you someone just scanned the network. And since it all came from the same IP, like, you really, really need to look into what is that IP, what is going on here. So that's a tip number one. Even just the most basic hacking reconnaissance can be seen in a SIEM. So let's do that. That's we just ran one command and already our SIEM is like lit up. Okay, so we know that this is a Linux server. Okay, so the way you get onto a Linux server is you can have the IP address here. If I could highlight things, let's see. Okay, there we go. Okay, so you can do an SSH command. That just means like a secure shell. I'm trying to remote that server. Okay, a hacker won't know the proper username by default. Okay, but the default one is root, so they're probably going to try something along the lines of root. Okay, they won't know the password, so let's try something. Oh, yep, didn't work. They might just start guessing. They might write a script to just pound through these 10,000 passwords. You know, just try them all until one of them logs in. I've seen that over and over, where anything that's internet connected these days and has like the potential for a username and password login, if it doesn't have a lockout period, you'll just hit constant. I mean, like every minute you'll have 1,000 attempts to, like, you know, just pound these credentials, and they're just trying to guess it. So same thing. So we'll just restart that so it sends its logs, but we should be able to come in here and see that someone failed the root login to this Linux server. So, okay, Splunk's been restarted. So that's what this is. Let me refresh this page here. So SSH failures. So this is what an SSH failure in the logs looks like. So this is at 12:32. So that was 30 seconds ago or something. So right here, failed password for root from, guess what, that same IP. Now this gives you option number two, or chance number two, for your IT security department to react. Someone scanned the network, someone has identified a Linux server and is attempting to log in with root. So, I mean, it's a best practice to not allow root to log into your SSH in Linux, because it's the default. Everyone guesses that, everyone knows that. Okay, so if they try an account that doesn't exist, you'll get this one, which is invalid user. But anyway, this should be going to somebody's inbox. Somebody should get a text message about this. Like, this is chance number two. You've got to catch a hacker. Okay, let's pretend they pounded that script for, you know, 4 hours, whatever it takes. They eventually are able to guess. No, not Cali here. They're able to guess that, because I built this environment, I know it happens to be sysadmin, not root. Yep. And I'll put in the right password. Now, granted, they would have to get the right password in this situation, but it's very likely to happen. They could start capturing network traffic, and they could eventually log in. So it's a successful login here. So let's see this. What machine am I on here? 24, Ubuntu 24. So I was able to come in from Kali into that. So I'm remoted to it now, so I can restart Splunk from here, so we don't have to switch over. And this also, so this will bring up an interesting concept. So I've remoted onto that machine now. That is an alert that we'll get in Splunk. That's another chance to catch them. Once they are on that device, they have to elevate their privileges. In Linux world, that's called sudo, kind of weird. Super user do is what that stands for. So in the logs, it'll say like root actually did it, even though it was sysadmin here, but I said super user do it. It's kind of a weird concept, but whatever. Bunch of nerdy stuff. Okay, so if they knew the password to get on, they will also know the password to sudo. So here, so now I've logged in successfully, and I executed something as sudo. Both of those are two new chances that we can catch this hacker. So here, successful logon at 12:35, so that was like 30 seconds ago. So again, there's that IP address. That gives you your artifacts. If you're starting to build, like, I don't know who 10.1.1.35 is, but that's no good. Like, there's clearly something going on from that IP address. You could jump into your firewall and just like, whoever that is, like, you're off my network, bye. We'll figure out who that was later. But anyway, it tells you they were able to log in with sysadmin. And here, these are the commands for sudo. So here, the session was opened. Session was opened for root. That's super nerdy Linux terminology for sysadmin right here escalated their privileges. They're acting as root. Once you're root, there's nothing you can't do. The device is yours. So that here in the once you have that they've used sudo, you can also see their commands. So this is good for reverse engineering, like in the middle of a hack. If you're trying to figure out, okay, what are they doing? What are they looking for? What are they trying to get out of our environment? You can capture command lines. So anything that you type into command line here, so if I do sudo hostname, and then I restart, so since it's logs, these commands will be captured. So you can see kind of like, if they're, hey, search the entire file system for the word password or for the word bank or routing or, crypto or whatever, then you can kind of get a better idea of like what they're after, what they're trying to do. Let's refresh this. Let's see, sort by time. Right there, hostname. Hostname was executed with sudo. So that's kind of a stupid command. You would never sudo hostname. It's just telling you the name of the device. But it tells you, like, quickly, you can reverse engineer, like, okay, what are they after? All that. So that's, I was change number 4 or 5, whatever we're on now, of like, now you have some pretty good, even just basic forensics to be able to control your environment, harden your environment. Earlier I was playing around in here, and there's, and it rolled off the page, but there are firewall commands, in Ubuntu, and so, if they're trying to turn off the firewall or trying to open ports or whatever, all that's going to be listed here. If they're, searching the whole file system, if they're taking Linux to try to break into your Windows servers, that's going to be listed here, all that stuff. So that's kind of an entire attack chain from the Linux side. Is at this point, it's the entire server's gone. Like, they're acting as root. There's nothing else that they would need to do any exploitation. If you have the same root passwords on all your Linux servers, they're just gonna be able to pivot, do whatever they want. So that is on the Linux side. Now let's look at, if we go back to here, to our initial scan. So in our scan, we noticed that 3389. That typically will only be open on a Windows server. That's a Windows Remote Desktop. So I can be reasonably sure that this IP address is a Windows server. So I can come into here, and this is just Remote Desktop for Linux. So I'm putting in that IP address, 10.1.1.10, and I'm just saying, hey, just go ahead and connect over. Sure enough, I get a prompt which tells me, if you get a prompt like this, it's Windows. I know I'm looking at Windows here, so let's say we don't know this, and so they might, administrator is a pretty default one for Windows. Administrator, trying to talk and type at the same time. Okay, but that account doesn't exist, so no matter what I type in here, it's disabled. I guess I shouldn't say it doesn't exist. So that should be showing up in the logs. So first off, let's see. Will that show up? No, it won't. So I'll switch over to the other dashboard here. I'll need to restart Splunk here so we don't have to wait 5 minutes. Wait for it. Oh, sometimes these VMs are a little iffy. Okay, there we go. Love me some PowerShell. Always do PowerShell for everything. Okay, so if I restart service, Splunk, so same thing. I'm just not waiting 5 minutes. I'm just sending Splunk its logs now. And if we come back into here, as soon as that's done, alrighty, so coming in Windows here. So the first one that we're going to be able to see is remote desktop failure. So this is at, wow, this is not the easiest date to see, 7/14, yeah, that's it. Let's filter this a little better. Wow, I think the time on this VM might be wrong. Anyway, so here it is. So these are only remote desktop failures. So somebody, that same IP address again, is coming in on administrator, but they clearly don't know the password because they're failing. Fail, 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 fail. Okay. So if, kind of same situation, if they eventually are able to find out what the valid username and password are, that would look like this admin. And sure enough, you know, actually let me log off because it will log a little differently if you take over a current session versus start a new session. So let me start just to make sure everything's going to show up correctly in my little demo. Okay, so let's say for however they did it, they captured network traffic, they reverse engineered the password, or it's the same as on your Linux servers, not cool. They're able to log in. Okay, so that's again another chance where you are able to catch them if you're watching your logs in a SIEM. So let's restart. So SIEMs can show you anomalies, which it does take some work on a human side where you kind of need to know your environment a little bit, where if you have static IP addresses for your admins, if you have 3 people, 10 people, whatever on your IT staff, you need to know those numbers and those names so that when someone successfully logs in, if it's not one of those 10 people, not one of those 10 IP addresses, it immediately creates a like, that's not okay, that shouldn't be. So let's look in here. So this is Windows 1. So right here. So see as admin logged in, okay? That might be a completely normal event. It's the domain controller, CS admin, they don't normally logs into the domain controller. There might be nothing weird or unique about this except for this IP address, okay? A SIEM can be tuned to the depths of like, okay, if this account logs in and it's not from this IP address, create an alert. You can do that. It takes quite a bit of work, or you create dashboards like this and you just make it a daily habit to just check every now and then of like, okay, who's been logging in, who's using this account, all that sort of stuff. And when you see an IP address that you don't recognize, that's your first indication of like, okay, that's weird. I've learned in the security world, success is by far the scariest of all logs, where like, you know, firewall blocked so-and-so, failed login, and like that stuff doesn't really scare me anymore. Anything that's on the internet is constantly getting hammered with fail. It's the successes that really freak you as an auditor of like, okay, soon as there was a success, now I need to know like what's everything that account did after it successfully logged on. What's, you know, you gotta do all these things. So that right there, again, another opportunity a SIEM could help you catch them. Okay, so I'm logged in. I executed PowerShell. That's what this window is. Let's open up command prompt. Do you even have command prompt in the start menu anymore? They don't, not on 2022. So I have to search for it. All right. Run command prompt. Super cool. Okay. Now we'll send off our logs again. Or just wait 5 minutes, either one. And you would set your alerts for, I mean, depending on the event, you can have it searching the logs for, like every 5 minutes, every 10 minutes, every 15 minutes if you want to. It just kind of depends on what's the action. If it's some crazy high-end, like when this happens, it's a very high chance that you've been hacked into, yeah, you might want to know every 5 minutes if that event has happened. A lot of other events, like maybe once a day is fine, like the new accounts that got created in Active Directory or something, like maybe you want every hour. You can tune a SIEM to whatever your risk threshold is. So let's refresh this, check our new events. So I opened up PowerShell. It is this event here. So sysadmin, there was no parent process because I right-clicked and opened command prompt. It wasn't like a service or something that executed it on my behalf. I did it. That's why parent process is blank here. I opened up command prompt. I opened up PowerShell right here. So that is, that's the full attack chain on Windows. Once you have PowerShell's admin, there's really nothing you can't do. You can take over Active Directory. You can take over a whole on-prem environment, essentially. So this is a really pretty basic tutorial on a SIEM, but any one of these things that you can detect, you can get an email on. And the nice thing is it doesn't all have to be security related. When I was a system admin, I used this constantly for just to know what was happening. Like the example I always kind of go to is I had a file server once, and I had the new file server and the old file server, and switched the DNS over and whatever, and I got the whole company using the new file server. But then I needed to prove that nobody was still on the old one before I retire it. Well, there's not a better tool than Splunk to do that, and firewall logs. And I could prove, like there were 2 people that were still using the old one. And sure enough, I go to their desk and I'm like, hey, I noticed you're still using the old file server. And they walked me through their process, and there on their desktop is an icon for the old, IP address of the server, the old file server, and that's what they click on every day. And I was like, oh, okay. Yeah, here, let's just change that IP to the new one, change those 2 people over, and I could safely retire the old file server without creating a bunch of help desk tickets, because I could prove that something was or wasn't happening. SIEMs are they're just amazing tools for understanding your environment. And so I've just demoed on-prem stuff because it's easy for me, because I can run VMs to do whatever I want. I can pull down the logs, I can restart the services and show cool dashboards really quickly. But the same thing happens in the cloud. You can pull down your Amazon AWS logs, your Microsoft logs, a lot of SaaS products have the ability to dump their logs into Splunk, and you can get alerted on events for there's a new admin user in your cloud service, there's a new service that was created, there's a new app that was registered on your tenant. All that kind of stuff. There's a new group created, new owners of the group, new members of the group, all that sort of stuff. In Microsoft world, you can, if you're using Microsoft for SSO, like single sign-on, if it's your identity source, you can know so much about your environment, because people have to authenticate to Azure first and then to whatever the app is. Well, you can see where'd they come in from, what device were they on, what kind of MFA did they do, all that sort of stuff on all these third-party apps, just because Splunk is watching, your identity provider. When it's a very powerful environment. You'll understand your world like you never have before. It's really the whole time I've been in IT, coming up on 20-ish years, and when I first saw Splunk, I was like, oh my goodness, the industry has needed this tool so badly to just know what's what. Half the battle in IT is just, I didn't even know what's happening or where to look, or There's so much information overload. Being able to create these kind of dashboards of like, if somebody's hacking remote desktop, all I care about is what device, what accounts are involved, what's the source IP, and like the time, that sort of stuff. I mean, it helps you peel out like, I don't care about these millions of events that are happening. I want to know if this one happened, and in this event, tell me these 4 things about that event, and that is how I make a decision. That's the power of a SIEM. So, appreciate everybody's time, and I hope you have a safe rest of your July, and you tune in next time for Cipher, and thank you so much.